Hello, all specialist maths students. It's Mr. Underwood here, and my apologies. I have been sick for the best part of three and a half weeks now, and I'm hoping to be back at work next Monday. But I thought I'd make this video, and this is one of the very first videos I've ever made without sort of being in a classroom environment. So I'm going to try and get through this as quickly as I can. If you ever sort of feel a need to sort of pause the video, my sort of advice would be please do so, take some notes. Now, you should have copies of these notes, and I've been through a good portion of these notes with my class, but I would like to go through the entirety of these notes as quickly as possible so the video doesn't go for an hour or so. My advice is to watch this video, and in addition to that, and doing any chapter 10 exam questions which you have solutions for, that would be the best way to revise for your SAC, which is of course on Thursday the 29th of August, component 1 and 2. So component 1 and 2 will have a kinematics part, it'll have a mechanics part, and then as outlined, the open-ended component will be mechanics, okay, with maybe a little bit of kinematics as well, because they're interrelated. First of all, let's just talk about Newton's three laws. It's really important to know that Newton's three laws, and I've asked a number of students before, including physics students, and they couldn't tell me. So to put it plainly, Newton's first law is Newton's first law of inertia, which is for an object will remain in motion or stay at rest unless acted upon by an outside force. So I guess if you think about it, if we think about this one, let's think about space. Okay, space. Something will just continue to travel on forever because there is no inertia, there is no resistance to motion. So of course, if you send a rocket up into the atmosphere, and then of course you send it towards the moon at, 100 meters per second, it will travel at 100 meters per second until it gets to the moon, and then it might sort of form an orbit around the moon due to its gravitational pull. Another thing, think about if you're standing on a train, what happens when the brakes are applied to the train, then what happens to you? Well, if you're not holding on to something, you're going to fall backwards, forwards, depending on the situation. Now, Newton's, this here, we've got two. When acted upon by a force, the magnitude of the force varies jointly with the mass and the acceleration of the object. Okay, so if I have a look up here, and for some reason I've got a little bit of an issue with my pen here. Okay, so just 1 second. I've just got to pause this. Okay, my pen's playing up a little bit. So just think about this as force equals ma. Now, if I apply twice the force, then to a mass, the same mass, then it's going to be then what's going to happen is that we're going to have twice the acceleration, and vice versa. If I apply a half of the force to twice of the mass, it's going to apply the same acceleration. So what we're going to say is that force is proportional to the acceleration. Okay, because of course mass stays the same, but if we increase the mass, then of course if we apply the same force, we're going to get less acceleration. So force equals ma is the two, and then number 3 is for every action there's an equal and opposite reaction. Okay, if I push against the wall's going to push against me, those sort of things. Now, you get some sort of pretty standard things when drawing diagrams. You need to be drawing diagrams properly, okay? Weight force, well, yes, in physics, it might be called force of gravity. I don't want to see force of gravity in specialist maths. A weight force is equal to ma, but a force, the acceleration of gravity is g, so mg. Okay, so for example, we're going to go into later that as well. Normal reaction force. Now, there's two things. There's when you stand on the ground, your weight pulls you down by the reaction force. But when the reaction force is perpendicular to the surface, we can sort of refer to that as the normal reaction force. So when we're looking at an inclined plane, to be honest, if you used N for both, that is perfectly fine. Okay, perfectly fine at all. Now, tension, use T, but sometimes you have to use T1, T2, for example, if there's more than one string, rope, etc. And friction, FR. Okay, now we're going to talk about later about how friction has been affected. Now, look, I've just given you an example here, which I went through with my class. Now, this question was done really poorly. Now, it said that basically this is what we call an equilibrium problem. And can you see here, this is the way I've set it up. And in actual fact, in my class, we did it in 1 minute and 56 seconds with me explaining it, which means that we actually saved ourselves a fair bit of time because it took me 1 minute and 56 seconds with explaining it. And of course, in the exam 1 setting, you'd get 4.5 minutes to do 3 marks. So we have just saved ourselves 2 minutes and 34 seconds. Okay, so let me just scrub this out, all right? And you can time this if you like, okay? Time this if you like, but basically this is the way to do these sort of things. I see too many people invent their own methods, and you can check the examiner report. Okay, first of all, if it's in equilibrium, the net force in the x direction is equal to 0. Okay, I'm going to rub this out over here. Okay, and you can see here that in the x direction, there's only 2 forces acting. There's one acting which is 120 at an angle of 30 degrees to the vertical. Okay, so what we've got is and that's to the right. So I'm going to do 120. Now I want this in here, which is the opposite to this angle. So that's 120 sine of 30 degrees minus, we want this in here now, which is T sine of 45 degrees, and that is equal to 0. Okay, 120 sine of 30 is 120 times a half, which is 60, minus T over root 2 is equal to 0, which implies that T is equal to 60 root 2. Done. We've just found T. Now, the harder part, though, is when I'm doing the net force in the y direction. That's equal to 0. Now, if I once again have a look at this, we've got 3 forces this time. We've got this one over here, we've got the component of this force, T. So now that's T cos of 45. And the reason why I've got T cos of 45 positive is because up is positive. Okay, and that's what I should always suggest unless we're looking at motion where it's actually moving. Okay, and then you've got this plus F over here. So we're just going to go plus F, and then we're going to go, we've got to go minus 120 cos of 30 degrees is equal to 0. T cos of 45 is T on root 2 plus F minus 120 cos of 30, which is root 3 on 2, which is minus 60 root 3 is equal to 0. Therefore, F is equal to 60 root 3 minus T over root 2, which is equal to 60 root 3 minus 60 root 2 over root 2 over 60. So therefore, that is your answer. Put a box around it. They can quite clearly see that. I don't know how long that took, but I don't think it's very hard. Please don't invent your own methods is what I'm trying to say. Okay, now in this one here, please heed our advice. The positive direction, the direction of motion is positive. Now, in this question here from 2009, a very simple sort of style question, but look at this. It's worth 2 plus 2, 4 marks. 10% of the exam is worth this, and if you get your signs wrong, you get 0 marks, quite simply. So force is equal to ma. Okay, this is Newton's second law. Okay, because the thing is the thing is going downwards. What we can say is our direction of motion is going downwards, like so. So MA, which is 50, because we've got a 50 kilogram student, times A, which is 50G. Just be careful. Let's draw a force diagram. We've got 50G, 50, 50G, and direction of motion is going downwards. And of course, our normal reaction force is going up, and that's all the forces we have. So you notice here that this 50G needs to be in the opposite direction of the N, okay? So 50G, yeah, now you don't have a calculator, but 50 times 9.8, 50 times 9 is 450. And 0.8 times 50 is 40. So it's 490 newtons minus 100. There you go, Woolly Wooshka. There's your answer. Okay, in the other way, and this is what happens when you're in an elevator. What happens is, if you accelerate upwards, the weight the weight you feel is actually referring to your normal force. Okay, so your normal force, the ground pushing up on you. Now, what happens is that when you're accelerating upwards, you're actually feeling heavier. So you've got to know that concept and have it in your bound reference, for example, because if you get a normal force which is less than the actual weight force, we know that the weight force is equal to mg, which is equal to 50 times 9.8, which is equal to 490 newtons. So if you're getting a weight force, if you're getting a normal force, which is less than when you're going accelerating up an elevator, then something must be wrong. So once again, over here, the direction of motion is positive. In other words, up is positive, which means this N is positive, whereas over here, N was negative. Can you see that? Okay, and as you can see, we've got the minus 50G is opposing the motion, is opposing this direction of motion. It's the opposite direction. It's a sign. So once again, there you go. I did it in 2 minutes and 14 seconds and it's supposed to take 6 minutes. Okay, and that was worth 10% of the exam. Okay, these connected particles are done really easy. But by the way, this is the last question of a multiple choice. Back in the day, so from 2006 to 2015, there used to be 22 multiple choice questions. Okay, now how did we get the answer, which is 3G? So what we're going to do is, first of all, we know that the direction of motion is for this connected particle is this way. But that means this means this way. So let's do two equations, and you can do this in your head in the multiple choice, I promise you. So let's do the equation of motion for the 5 kilogram. You don't have to write anything down, but you know there would be 5g minus t. Okay, so let's minus t is equal to ma, which is 5a. And the other one we would have 2a is equal to, be careful, the signs are going to be 2g plus t. Now, when you add those two together, you know that they're going to cancel out. 7a is equal to, 7a is equal to, what have I done? Oh, let's see, have we made an error here? I think we might have. Let's have a look. So what we've got to do is let's have a look at what we've done. We've got 5a is equal to the direction of motion 5g minus t. That's correct. Okay, what about for the 2 kilogram particle? The direction of motion's upwards. So what we can say is that we've got t minus 2g. There's the problem there. Okay, is equal to 2a. So therefore, when you add them together, we're going to get 7a is equal to 3g. So therefore A is equal to 3G on 7. Yay! Not that bad, is it? Okay. Now, I'm going to just pause this video and I want you to put a bit of a timer on this. Okay, so we're resuming. Now it's sort of, here we've got exactly the same thing. We've got a connected particle, and of course our direction of motion is going to be going this way, and then the other one's this way. So we want to actually find the acceleration, which is, of course, these are connected particles, so they're going to have the same acceleration. So what we're going to do is about a 3 kilogram, given the fact that the direction of motion for the 3 kilogram is going downwards, we can say that 3A is equal to 3G minus T1. We're going to call that equation 1. And about the 1 kilogram mass, we've got the direction of motion is positive. T over here, T1 is going to be positive. And we've got minus G is equal to A, equation 2. We're going to get equation 1 plus equation 2. That's going to give us, we're going to have 4A is equal to 2G. So therefore your answer is A is equal to G on 2. Stop. You can leave everything in terms of G, okay? Unless asked otherwise. So stop. I'm sure if you did your timer, that wouldn't have taken long. Find the value of T1. Well, therefore, if A is equal to G on 2, therefore, we can say that T1 minus G is equal to G on 2. I'm just using equation 2 above. I'm just trying to do this as fast as I can. So therefore, T1 is equal to G plus G on 2, which is 3G on 2. No need to, because it's worth 1 mark and it does not say show. You can just simply write the answer if you are swift enough. Now we're starting to get to things which are a little bit harder. Okay, now I'm going to leave this and just pause it for a second. Okay, and I want you to have a little bit of a look at this question. Okay, so look, I'd like you to time me for this one because basically you can make up, if you see these questions on exams, you should be laughing because you should be able to, number one, nail them, and secondly, save yourself a lot of time to answer some of the harder questions. All right, so it says here, when theta is 30 degrees, the acceleration of the 1 kilogram mass upwards. Okay, so that means that the direction of motion is that way, which means the direction of motion for this thing is this way. Now, just so you know, it says here that it's a smooth plane. So smooth means no friction. We'll get to friction later, okay? We'll get to friction later, and we're going to do friction questions, and there will be friction questions on your SAC, I can promise you. Now, when theta is equal to 30 degrees, the acceleration of the particle. So let's go ahead and do the net forces. Now, we don't care about the net forces perpendicular to the plane. So what we're going to do is we're going to do about the 3 kilogram object. Okay, about the 3 kilogram object. Now, the direction of motion is positive. So what we're going to say is we've got the component of the weight force. 3G sine of 30 degrees is positive minus T2, and there's no other forces acting parallel to the plane. That's it. And that is equal to 3A, force equals mass times acceleration. Now, what about the 1 kilogram object? Kilogram. Okay, so we can say that we've got T2 and then we've got minus G is equal to MA, but the mass is 1 kilogram. So that's going to be just A, 1 times A. I'm going to call that an equation 2. Now we haven't found, now look at this, 3 marks, 4.5 minutes. We've always done it. So what we're going to do is we're going to go 1 plus 2. Okay, be very clear with what you're doing here. Okay, which is going to give us 4A is equal to 3G sine 30 is equal to 4A is equal to 3G on 2 minus T2 plus T2. That's the trick, isn't it? They're going to cancel out. And then what we've just simply got is we've got minus G. Now, therefore, what we can say is we've got 3G on 2 minus 2G on 2. Therefore, we can go straight to the answer. A is equal to G on 8 meters per second squared. But technically, for some stupid reason, they've said, what is B? So therefore, B is the acceleration. B is equal to G on 8. You don't have to write meters per second squared. And then we're done. Now, it says here that we're at 20 minutes now. Find for what angle theta will the 3 kilogram mass be at rest in the plane. So you can see here that I just want you to just pause the video now and have a look at the diagram that I've drawn. It's exactly the same, okay? It's worth 2 marks, okay? But this time it's in equilibrium. So it's exactly the same as before. You can see over here this T, well, actually, did I use T2 before? Yeah, I did use T2. So I've actually just drawn over here T and T1. So technically there's a T2 there. So T2, which is this thing, I'm going to just go, in this case, it's not moving, it's in equilibrium. So I'm going to call up the plane as, positive, and I'm going to call down the plane as negative. So basically what we're saying is that T1 minus 3G sine theta, that's 3G sine theta there, they're the two things acting, it's smooth, and then I use my calculator, okay? So there's your answer mark, there, and then there has to be some method mark there, okay? And it always, I think, drawing a diagram like this helps you recognize that as well. And once again, we can do that in 1 minute and 50 seconds anyway. Okay, now be careful. It says correct to 1 decimal place. If you go ahead and do 19.52 or something like that, you lose your answer mark, which is just crazy, isn't it? It's unfair, but that's just the nature of VCE, unfortunately. Now, a block M. I just want you to have a bit of a stop and a pause and a read of this. Okay, I'm just going to pause this for a second. Okay, so have a good read of it. I've drawn the force diagram. Notice that I've got N, my normal reaction force, perpendicular to the plane. I've got T1, which of course, now think about it. T1, for every action, there's an equal and opposite reaction. That's Newton's third law. That's why these T1s equal. These things equal, okay? Because, of course, you've got T1, so especially when we're talking about ropes and strings and things. That's how it works there. And if you're standing on the ground, for example, if you're standing on the ground, okay, then you have a weight force which is equal to mg. Okay, let's just say if you're 50 kilograms, 50g, which is 490 newtons. And of course, then there's going to be a normal reaction force initiated from the ground, okay, and that's also going to be 490 newtons. Okay, now just quickly, what are we at? We're at 23 minutes. So you can see here it says a block of mass M. You've got to read these very carefully. A rough plane which is inclined at 30 degrees is now connected. Now, to be honest, nowadays they've actually simplified the mechanics course, but your SAC is including rough planes because you need to practice from 2006 to 2015 questions like this, and you can't do so without knowing so, and quite frankly, they should not have removed it from the course. So it says here, if the block is moving down the plane, clearly label all the forces. Now look at that. If I just can show you, that's 2 marks. 2 marks, okay, for writing mg, okay, which is directly down. That's what the block is, okay. I've just drawn a little sort of a coordinate system here, which is going up the plane is x, and going down the plane would be negative x. So you can see here drawing T, and of course friction opposes motion. So it says here the block is connected, and if a block is on the point of moving down the plane, on the point of moving down the plane means the net force is actually 0 on the point. Okay, so the net force is equal to 0. That's very important. So you get 2 marks just for doing that. Now it says write down but not attempt to solve the equations. So what I've done is I've done the net force in the x direction and the net force in the y direction, if you like. But as you can see here, it says here though, but do not attempt to solve the equations involving the forces. So why solve them? You've just been asked not to solve them. So what we can say is, now I've gone up the hill. So T1, T1, T1. Okay, friction opposes motion. So it's about on the point of moving. So friction is going up the hill minus mg sine of 30, which is this thing here. This component of this force is mg sine of 30 degrees. And then that is equal to 10 times A. Okay, now the thing is though, is that A, write down, so this 10A is equal to 0. Okay, so what you can do is you could make your life a lot easier. Okay, I'm not going to finish it for you. Okay, but you can also see that there's the other one is over here. If it's on the point of moving down the plane, then that means that 10g, that's fine. 10g minus t1 is equal to 10a. That's true, but a is equal to 0. So therefore, T1 is equal to 10g. See where we're going here? Because I reckon we could maybe sub that in later. Now, just quickly, I'm going to rub this out, okay, because I was doing this really fast before, and I'm going to do it from scratch, okay? Now, we almost got there. So from the first one, it says that we just worked out that T1 is equal to 10g. Now, I've got this is correct, but this is equal to 0. Okay. Now the thing is though, is that when you have friction, friction is equal to mu n. This is the maximal resistive force, where n is the normal force. And it says here the coefficient of friction is equal to 1 over 4. Okay. So we had to do the net force in the y direction over here, okay, which means that basically we're looking at a block. This block is not going anywhere in the y direction. Okay, this is the y direction. Okay, it's not going anywhere. So what we can say is, and you can do it quite quickly, you can say that n is equal to mg cos of 30 degrees, which is equal to mg root 3 over 2. Now, we've got all the information. We also know that T1 is equal to 10g, which we just worked out from before. And now we've got to somehow prove that this mass is equal to this. So what we can do is, using equation 1 dash over here, so equation 1 dash states that we've got T1 plus friction, well, we know what T1 is, minus mg on 2 is equal to 0. I'm going to rub all this out, okay? One small calculation error, which I make them too, especially when I'm trying to do exams in half the time. So let's take our time, okay, is this. So what we've got is, do we know T1? Yes, we do. 10g, okay, plus friction. Now, the friction is mu n, which is 1, so it's plus over 4, and n is mg root 3, which we just worked out over here, okay? And we also, n is equal to mg root 3 on 2. So therefore, that would be mg root 3 over 4 times 2, like so. Okay, so because this is mu n. Friction is equal to mu n. We've just got n over there, so we've got to multiply that by 1/4. So we've got now m minus mg is equal to 0. A lot of students didn't do very well in this because they just get too muddled. Okay, so the only thing that we don't know is m. So what I'm going to do is I'm going to do this. I'm going to get m out as a common factor, and I'm also going to get g out as a common factor. And what we've got is we've got 10 plus, let me just do this. I'll take my time. I'll take my time because otherwise I'll make a mistake and you'll think, geez, Mr. Underwood is a terrible teacher. Okay, so mg root 3 on 8, root 3 on 8, and then we've got minus 1. Is that right? 10, oh, that's 10g. I'm a dill, aren't I? Oh, okay, so let's have a look. Let's just try this again. So 10g, so I'm taking out mg as a common factor, which means this 10 needs to just stay there. And I've got root 3 on 8 mg minus 1. That's better. Yes, I'm a lot happier with that. Is equal to minus 10g. Let's just get to the other side. No. Yes. No. Yes. Yes. All right. Actually, I'm going to keep that. I'm going to keep that 10g over this side. And by the way, it says here show. Can I just show you? Show. So if you just reverse engineer and you just skip steps and just pretend as though the examiner's not going to notice, you're in for a big treat. So that's fine. Sorry. We're going to say plus 10g is equal to 0. Now, what we could do is we could actually just decide to take out g as a common factor. Let me just think about this. I think I've worked it out. Okay, so I've done this. I've just changed that to a fraction. Okay, and the g's are going to cancel out. And we've got n, and then I've got root 3 minus 8. Minus 8. My pen's dying again. Let me just see if I can fix my pen. Okay, so I just wanted to show you something, and maybe I did this in purpose. Can you see over here? I haven't carried this mg on 2 over here, and that's going to make life very difficult, because all of a sudden you're going to spend longer and longer on a question worth 2 marks, and I just wanted to show you that. So I hope that you can see there. You can go there, and then you go. You get stuck, and then you get stuck, and then you get under pressure. This is an exam too, but it's to show that question, so you've got to show everything carefully. So let's try it again. Okay, so as you can see there, now that I've got that mg on 2 there, life makes life a little bit easier. Let's get everything over. Let's get everything over 8. So that's going to be 80g plus mg root 3 on 8. Okay, so 80g on 8 minus 4mg over 8. Oh, look at that. Isn't that just brilliant? Now the thing is that you need to make these mistakes yourself. I can make them for you on a video, but now I can go 80g is plus mg root 3 minus 4mg is equal to 0. Okay, multiplying through by 8. And now I can take out g as a common factor, which gives me 80 plus m root 3 minus 4m. That's looking a lot better because we divide through. So therefore we can say that 80 is equal to 4m minus m root 3. Wow. 4 minus root 3 on 80. Therefore, m is equal to 80 over 4 minus root 3. Now, look, I know that was long-winded, as required. But what I'm saying to you is this. If you rush these sort of style of questions, some of these harder ones, you're going to make mistakes because I didn't carry this mg onto over here and I made it mg. That actually started to throw me out, okay? And I've been teaching this subject for coming up to 10 years now. So there you go. Tricky question as well. Okay, now let's just try to catch up on some time. It says here we've got a model glider is suspended from the roof. Now, suspended basically means that it's in equilibrium. Now, it says here, let T newtons be the tension, clearly label all the forces. Well, T is the tension's away from the mass, and we'll see why in a moment. It's in equilibrium. It says here that it's 4 kilograms. By the way, if you write 4 kilograms, okay, you will lose your mark, okay? What do you have to write? You have to write force equals MA, which is 4G. And then finally, the only way this is in equilibrium is if there's a force to the right, and that says G on 2. Now, you don't have to be too cute with this, okay, but let's just say that we've got G on 2 like so, G on 2, done. There's your 1 mark. Would have taken you about 12 seconds if you read the question in the reading time. Now, it says calculate the value of T. Now, look, here's the thing. There's a section of the textbook called, which is Lami's theorem, okay, which I think is only really good. Lami's theorem is only really good for multiple choice exam questions, okay? So what we can say is that we've got, but I'm going to do this a different way. I've got 3 vectors which are in equilibrium. And of course we know if there's a triangle of vectors, if 3 vectors are in equilibrium, then we can join them head to tail. So why don't I do so? So why don't I go, I've got over here, let's just call that T, and I'm joining my 4G down here, which is head to tail, 4G, and then of course I'm going to join that. Are they all head to tail? Have a look at it. I think they are. Okay, so how's this 2 marks? Okay, if you don't know what you're doing though, you could spend 7 minutes doing this question. All right, well, you can put your timer on now, but what we can say is that, that T squared is equal to 4G squared plus G on 2 squared. 4G squared is 16G squared and G squared on 4, like so. That's going to be 64G squared on 4 plus G squared on 4. So therefore, the answer, go straight to the answer if you like, that's fine. That implies that it's not a show that question. T is equal to, now we've got 65 of them, and we've got the square root. So it's a square root of G squared. So it's G root 65 and the square root of 4, which is 2. Put a little box around it. Please the examiner. There you go. There's your triangle of forces. Okay. Now, just remember that take the acceleration due to gravity to be 9.8. That is always the case. It says here, answer in terms of G are accepted as exact answers. Okay? Don't go writing things unless the question asks correct to a certain number of decimal places. Okay? Always assume unless asked. It's now let's have a look at this. Now I'm just gonna sorry, I'm just gonna pause. Okay. How long are we at now? 40 minutes. Let's see if we can get it done in 10 minutes. Okay, I'm back, and let's see if we can get through this. You can just pause and stuff. I think we can get through this in 20 minutes, which means you can sort of have a good look at the video and pause it and stop it and stuff like that when you're revising for your SAC. Okay, now yes, you can do this stuff, this exam 2 stuff, but you've got to be able to read the question very carefully. The diagram below shows particles of mass 3 and 2 kilograms joining a smooth plane. So that's nice to hear, with the inclinations theta and 2 theta. So of course the angle here is twice the angle over there. Now, it says here where theta is measured in degrees, the masses are connected by a light and extensible string. They'll always say that, a light and extensible string, and with a smooth pulley. The smooth pulley just means that there's no friction in the pulley. The tension of the string is T newtons, so be very careful. You've got to use what they've said, and the acceleration up the plane of the 3 kilogram mass. So we write the direction of motion, okay? Which means that if that's going up the plane, that's going up the plane, because that's going to tell us is an acceleration up the plane of 3 kilogram mass is A meters per second squared. For the 3 kilogram mass, write down the equation for its motion up the plane. So we know that we've got here, this is theta. Now you've got to be careful. We don't know what theta is. So we've got to be careful. We've been told that it's tension T, and we've also been told that it's a smooth plane. Now, there's no friction because it's a smooth plane. So therefore, what we can say is so we can say that T minus 3g sine theta, it's an equation. You can't just write that. It's T minus 3g sine theta. There's motion. So it's force, it's Newton's second law is equal to 3a. And then you stop. Okay, 1 mark, stop. Don't do anything more. For the 2 kilogram mass, write down the equation for motion down the other plane. So down here, there's this sort of, this angle here is 2 theta, okay? And the direction of motion, the weight force is actually going to be down that plane. So we're going to say that, we're going to say that 2g, well, that's 2g is the weight force, but 2g sine of 2 theta minus, there's a t there, like so, is equal to what? I want you to think about it. What is it? Have a bit of a think about it before I do it. That's right. It's 2a because mass times acceleration. And we stop. Show that a is equal to g sine theta, blah, 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 blah. 2 marks. So we're going to call that equation 1. We're going to call that equation 2. So therefore, what we're going to do is we're going to add equation 1 and equation 2 because these t's are going to cancel out. 5a is equal to 3g sine theta. Oh, no, it's minus. That's not very good, is it? Try to rush things, ladies and gentlemen, and this is what happens. It happens to the best of us. So we've got 2g sine 2 theta minus 3g sine theta. Now,
Sorry. Okay, so we've added that. Now we've got to wonder, how do I get to this? Just gonna have a bit of think about it. What I'm thinking is, you've got a cos theta here, you've got sine theta as a common factor. I was sort of thinking along the lines of, if, as I say, as Confucius say, as I said in my lecture, knowledge at fingertips. Knowledge at fingertips. Okay, you should know that sine 2 theta, 2g, sine 2 theta is 2 sine theta cos theta. Wow, look at that. I reckon we're getting somewhere here. Okay. So now we've got G as a common factor at the moment on the right, and all of that sort of stuff. We've got sine thetas. Sine theta is a common factor. So why don't we do this? Why don't we say that that's 4G sine theta cos theta minus 3G sine theta. Wow, look at that, 5A. I reckon we're almost there. Because if we take out G sine theta as a common factor, if I take G sine theta out as a common factor, that gives me 4 cos theta minus 3. Wow, look at that. So therefore, have we skipped a step? No, we haven't. A is equal to G sine theta over 5, 4 cos theta minus 3 as required, or you can say QED or whatever you like. But can you notice there that I haven't reverse engineered? If you use the answer to work backwards, 0 marks. I'm sorry, but too many students do it. So I just wanted to make that point. Find the angle theta for the system to be in equilibrium. Now, once again, to be honest, I haven't touched a calculator the whole time. Haven't touched a calculator, even though this is exam 2. So let's do this. For this to be in equilibrium, what we're going to say is we're going to have to look at our things, and we're going to have to say that for what angle theta is the system to be in equilibrium? Well, the thing is that unfortunately below we've been told that there's an acceleration. So why don't we go this? Why don't we say that the same rules apply? Okay, so we can say that t minus 3g sine theta is equal to 0 in equilibrium. And we can say that 2g sine 2 theta minus t is equal to 0. Therefore, we can add them together. I'm going to call this equation 3, and I'm going to call this equation 4. I'm going to add, therefore, equation 3 plus equation 4. Now, look, you've actually done, there's a method mark. You can go straight to the answer, but I'm doing it without a calculator, which quite frankly is a little bit silly. But what we can say is when we add those, we've got 3g. So we've got 2g sine of 2 theta minus 3g sine of theta is equal to 0, and you have to use your CAS. Okay, solve for theta, and you can find the answer out to that one. Okay, it is the 2000. Well, you'll be able to find the answer out quite easily. Okay. Now consider a chain situation where theta is fixed, and the supporting mass is this.
is now rough. We've been through this exactly the same question. It just makes you will not get this anymore. No, only in the SAC. In SAC 3, yes, we will. But in the exams, you won't, and I'll explain that in a second. Questions such as this should be bread and butter questions. You know, basically, if I've got a 12G force here, and then I've got an angle, okay, now that angle in there, okay, is 60 degrees. That's angle in there, 60 degrees. This is where I'm talking about Lami's theorem might actually work. Now, it sort of says here that the angle, if that's 60 degrees, and they're in equilibrium, I'm going to call this T1. And in actual fact, if that's the case, then that means because of the they share the same angle, 60, 60, 60, then in actual fact they're going to that's going to be what's that going to be there? Like sort of 30 degrees there, and that's going to be 30. No, 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 no. That's just silly, isn't it? That's going to be 60 degrees in there if you wanted to, and that's going to be 60 degrees in there. So what I'm saying is that's going to be 60, and that's going to be 60. This is where Lami's theorem might help, because you can cover up this 12G, so it's going to be like 12G over the sine of the angle between the other two. That is 60 degrees, sine of 60. And that's equal to T1. Now, if I was to cover up one of these, what's the angle between the other two? So we've got that. What's that angle there? So we just sort of said that's 60, so that's 150 over sine of 150 degrees. Now sine of 150 degrees is the same as sine of 30. So 12G, and then that's going to be, what's that? So root 3 over 2 is equal to T1 over sine of 30, 1 over 2. That's going to cancel. So T1, the magnitude of newtons of tension, T1, is equal to 12G over root 3. Now, does that present itself? No, but what about if I multiply it by root 3 on root 3? That's going to be 12G root 3 over root 3, which is 4 root 3G. 4 root 3G. Look at that. And we use Lami's theorem. Okay, Lami's theorem, which was an interesting one. That's probably the only time I reckon you should really ever use it, in all honesty. Okay, where are we looking at? I know that this is a long video. Okay, still under an hour. That's an hour for the whole mechanics course. Okay, so I'm doing my best here. A 5 kilogram parcel is on the floor of a lift that is accelerating upwards. The reaction in newtons to the floor of the parcel is, you know that one. I'm not even going to bother doing that one with you. Okay, this is where we get into the changes to the specialist maths course. So now this is on Sector Learn. In VCAR's attempt to try and cut time out and make up for the intro of probability and statistics without really actually taking anything out, there have been some simplifications to the mechanics course. I personally don't agree with these cuts, as exams with coefficient of friction are no longer sort of, I guess, that in actual fact you guys will have a deeper understanding. That's what I think. Here at Ivanhoe and in the textbook as well, we will still teach the concepts around friction and the relationship between the surface and friction. What's been removed from the course? Of course, you can see here, this is a question here where we've just done, that's fine. Okay, that is completely fine, but it's here. You will not be tested on this.
where you've got you've got to find the angle, you've either got to find theta, the coefficient of friction, or some unknown mass of which a particle is going to either, there's two cases, it's either going to go that way, direction of motion, on the pointer moving that way, or on the pointer moving that way. Now, I would like you to, look, try this question, please. Try it on the board with me. But basically what you need to do is you need to consider two cases, that the particle's moving up the plane. So if a particle is moving up the plane, so let's say case one. So if the direction of motion is that way, then the only thing that changes is that your friction is opposing the motion and nothing else changes. It's a shame because these questions are really good for the kids. Now, the other one, case two, is the direction of motion is on the point of moving down the plane, which means that friction opposes motion. Okay, and that was the only thing. You could easily do those questions. I'd encourage you, for anyone that wants to get it over a 35, I want you to do them anyway, just for fun. Now, so let's start looking about what mechanics questions looks like from 2016. Now, in 2016, 10% of exam one was on mechanics. Okay, and here's the question. Okay, I've got it right here. We're going to do it. And then there were two multiple choice questions, just two. But however, there was not an extended response question in 2016. So looking at that, there was 6 marks out of, so 10% of exam one. 10% of exam one was mechanics. So if you know mechanics, I've got a feeling this year it's going to be about the same. Okay, and there was only 2 multiple choice questions, and they are the sort of ones that you can solve using Lami's theorem, etc. Okay, and I can show you ways of doing those. So let's do this 2016 exam 1 question together. A taut rope of length 1 2/3 meters suspends a mass of 20 G. Okay, so we've got 20 G mass. Okay, from a fixed point. A horizontal force of P newtons displaces the mass by 1 meter horizontally, so the taut rope is then vertical. Show all the forces acting on the diagram. Okay, so we know that this is in equilibrium. So you've got to draw 20 G, and then you've got to draw, now be careful, horizontal force. We're just going to write T for tension. Okay, T for tension, done. There you go, 1 mark, the easiest mark. Show all the forces. Show that sine theta is equal to 3/5. So what we can do is we can do this. We could sort of, we know that this is, it suspends the mass, which means it's in equilibrium. So we can say, we can draw P here, okay, and then let's draw P, and then I can draw T there, and then I can draw 20 G there, all tail to tail. Okay. Now the thing is though, do we know anything else? It says here the rope of 1 2/3 meters. Now suspends a mass. Theta. We given anything else? So for question 1, it actually stumped a few students. I'm telling you, it stumped a few students. So I'm just going to have a little bit of a think about it, because in my reading time, that's what I'd be doing. Okay, so I've just drawn a little diagram up here. It displaces, we've got 5/3, a rope which is 5/3 meters, and I've got here angle, and I've joined them head to tail, as I sort of said. So therefore, I've just got here that I've got the opposite. So I'd say that sine theta is equal to opposite over hypotenuse, which is equal to 1 over 5/3, which is equal to 3/5 as required. That's all you need to do. Now it says find the magnitude of the tension of the rope in newtons. Okay, so what I would do is I've got an angle theta here. Now, angle theta is, sine theta is 3/5. But what I would sort of say is we could do this in a number of ways. It says you find the magnitude of the tension of the rope. So once again, this is one of those ones. It's actually surprising. It's tricked a lot of kids in the 2016 exam. Now we could do this. We could consider that we've got to find the magnitude of the tension of the rope, and up here I've got t squared is equal to 20g squared plus p squared. That's one thing. The other thing that I've noticed though is that this looks to me like a Pythagorean triangle. So, well, we can see that. But the question is, we've got an unknown mass. We know that we know t is. What I'm thinking is we need to basically go, okay, we know that t, so t over here, we've got to be very careful. Okay, if that's theta, okay, that's 90. This is, so 90 plus theta, that's 180 minus 90 minus theta. Okay, which is not, that's 90 minus theta, is that angle there. Or we could just simply find that component of that. So we want to find this force here. So what we can say is that t cos theta, that's why they asked us to find sine theta. These are the relationships you need to make by doing practice exams, okay? So t cos theta minus 20g is equal to 0. So therefore t cos theta is equal to 20g. And therefore, since this is a Pythagorean, so cos theta is, well, we've got a 3, 4, 5 triangle. If we do, this is why I've talked about this. If the opposite is 3 and the hypotenuse is 5, then of course we've just got a Pythagorean triangle. So cos theta is equal to 4 on 5. So therefore we can say that t cos theta is equal to t times 4 on 5 is equal to 20g, which implies that and they want the answer, they just want the answer, 100g, 25g. No need to write newtons. That's fine. That is perfectly fine. And look at that. Now, I'm going to pause this, and 2016 exam 1. Let's see how students went on that. All right, isn't this amazing for drawing the forces? It says students are expected to label a tension force acting up the rope and a weight force 20g acting downwards. Only 60% of students got the mark, which is, like I said, just ridiculous. Everyone could quite clearly
realise that sine theta, 93% of students got that. And look at this. Almost 40% of students got 0. Now, 245 is the same, is acceptable in units, but of course I wrote 25G. So it says here that it basically says, it says that there's other answers are accepted. So 250G, sorry, 20, what did I say? 25G is 0.8, yeah, so that works out fine. That's fine. All right, they've just given you your answer in newtons. Okay, so we're almost done. We are almost done. That's the 2016 exam. That was the first one. That's 10% of the exam. Okay, you just quickly, these sort of questions here, particle of mass, force, and this. These are basically the reason why I don't spend too long on these questions is there's usually a multiple choice question, and you would have practiced it over and over again. A particle of mass is subject to a force of 12I. So remember, force is equal to 12I plus 9J. But that's equal to MA. Okay, if no other form the magnitude of the acceleration, so therefore, so 5A is equal to 12I plus 9J. So 12 divided by 5 is 2.4, 9 divided by 5 is there you go, done. Could have done that in your reading time, couldn't you? What we've talked about Lami's theorem, you could use Lami's theorem for this, but notice that this is a Pythagorean triangle, which means that is a right angle. Okay, you can join them head to tail and all that sort of thing. And once again, I'm not going to go through that question. How can I just clear all collapse? How do I do this? Okay, that's better. Okay, so we're almost there. The whole course. Now, this is another example of exam 1 since the new course. As you can see, there's not going to be any mention of coefficient of static friction. They might say frictional forces. Let's do this one together very quickly. Or in actual fact, I'm going to pause it, okay? And I want you to have a go at this one right now, okay? See if you get the right answer, because I'm going to go through it once you give it a go. Now, let's time yourself, get a timer, and I'll see how quickly you can do it. So I want you to pause the video now, and I'll see you in a second. Okay, so I hope you had a good read and try of this question. Start timing. Let's go. Okay, so we've got, all you need to do is we've got an 8G there, which is the weight force, which is 8 times 9.8, which we can just leave it in G. Now, you can do R, be careful, it needs to be perpendicular to the slope. Okay, N, now we've got T acting and T acting here, and it says here 5G. Now, would you believe that only 60% of students got that one mark? Find the magnitude and state of the direction of the acceleration now of the 8 kilogram mass. So the acceleration of the 8 kilogram mass, you have to read it carefully. It says the 8 kilogram mass is a smooth plane shown vertically. Find in the and state the direction of the 8 kilogram mass. Okay, so what do you think's going to happen? Well, let's do the equations of motion. So I'm going to do that way as positive, and
that way, so if that way is positive, then that means that way would be positive. That way would be negative for this one. Okay, so what we're going to say is I'm going to say that I'm going to go up the plane. So for the 8 kilogram mass, we can say that T minus 8G sine of 30 degrees is equal to 0, equation 1. And so therefore T is equal to 8G sine of 30 is 4G. But here's the problem. It's not, it says there's an acceleration. So it's not 0, is it? It's equal to 8 times A. So we're not quite done yet, are we? A lot of people will sort of do that, make that mistake. And I just wanted to show you that's the common mistakes students make. Okay, so that's equation 1. But we're still going to do this in heaps of time. 5 kilograms, the 5 kilogram mass, we're going to say that 5G minus T is equal to 5A. Call it equation 2. So therefore, let's add what these things are. So we're adding those equations. We've got 13A is equal to 4G plus 5G. But I want you to think about maybe, is this right? I want you to have a little bit of a think about it. Okay, I'm just going to pause it, have a bit of a think about it. I made a mistake here. Okay, so I hope you've had a little bit of a think about it. When you have two connected particles, I want you to consider that you can also do it this way. Okay, and it's just another way to consider it. Basically, let's just say here's a tension. Now, forces are equal and opposite. Okay, so we couldn't give a hoot about those. This is a physics thing as well. But then you've got so basically what you've got is you've got a T, they're going to cancel out. You've got 5G, you've got a 5G, 5 times 9.8 force going that way. But you've actually got 8G sine 30 going this way. So you don't know what the direction of motion is, which is the problem. Now, if you had this, which way do you think the direction of motion is? Now, 8G sine of 30 is 4G. So here's the funny thing is this can be and you could do this, and this is a good one to do in Year 12 physics as well. Let's have a look. Those two cancel out. What's the net force? The net force is equal to, we've got 5G to the right or 5G down, and minus 4G pulling to the left, if I was to consider this as just in a vertical. So in actual fact, it's going to be G meters per, G is going to be the net force, and that means that the direction of motion is down, and that was the problem. I think that would be the problem for this one. This method could be used, okay? This method could be used. So, given the fact that we know, because we don't know which direction it is, we now know that based on that, that's direction of motion down. So that now we're going to have no issues with our signs. So let's about the 8 kilogram object. That means that T minus 8G sine theta is equal to 8A. That's fine. Okay, but 5G minus T is equal to 5A. That's also fine. But in actual fact, the net force, the net force is equal to the net mass. Okay, the net mass times the acceleration. Now, when you combine these two together, just like you've done, 5 plus 8 is 13. So 13A is equal to G. So you could have actually done it this way. Therefore, A is equal to G on 13 meters per second squared, like so. Could we have done it this way? Is there an issue here? I think so, because of this thing here. This is this sign error. Okay, if this was equal to 5G minus 4G is equal to 13A, you can see clearly that A is equal to G over 13. So what have I said all along? Sign error is the most important thing. Okay, and this is the last question. I know it's been a long video, but we've gone through all of mechanics, all of chapter 13. Now, I want you to read this question. There's a relationship between kinematics, mechanics, and all of those sort of things, vector calculus, and etc. Have a read of this question. I want you to try it. This is from the 2017 exam 1, and look at that, 5 marks, 12.5% related to this. So it's pretty important sort of stuff, particularly for your exam 1. Have a go at it right now. Okay, so the last question, you can see here from the 2017 exam, relationship between force, vectors, vector calculus, variable forces, these sort of things. So it says a particle of mass 2 kilograms with an initial velocity of 3I plus 2J, so at t is equal to 0, V is equal to 3I plus 2J. Let's write that down. Let's write down that. I think that we're going to need that for later. Experiences a constant force for 10 seconds. Now, force is equal to MA, so it's 2 times A, like so. The particle's velocity at the end of the 10 seconds is equal to this. Now, if you think about just physics in general. So the acceleration is equal to the final velocity minus the initial velocity over time, isn't it? Okay, V is equal to U plus AT, if you like. So if we can see here that the particle's velocity at the end of the 10 seconds is 43I. That's V, that's the final. 43I minus 18J. Let's get our signs right there. Let's use brackets. And it says with the initial velocity of 3I plus 2J. So minus 3I plus 2J. Okay, and then that's over time. Now let's do that. That's over time. That's over 10 seconds. So that's going to be 40I. So that's going to be 4I because it's 40 divided by 10, and then minus 18 minus 2 is minus 20 divided by 10 minus 2J. We've found our acceleration. So therefore, our force is equal to 2 times our acceleration, which is 8I minus 2J. But are we done yet? Well, force is a vector. So we've got force in some direction. The magnitude of the force. So with the magnitude of the force is equal to the square root of 8 squared plus negative 2 squared, which is equal to 64, 68. The square root of 68. Is that right? 4 plus that, 68. Now, it says in newtons. So let's just have a think about this and just want to see if this is the right answer. So I was looking at this and I'm sort of thinking, can you notice the mistake I made? Because we're all going to make them. And by the way, 5 marks in question 9. It's easy to make a mistake. 2 times A is, so force is equal to
2 times 4, which is 8i, these calculation errors are going to cost you. In actual fact, you would have lost all 2 marks. So let's change that to minus 4j, which is a minus 4 squared. And 4 squared is 16, 64, that's the square root of 80. 16 times 5 is 80, which is equal to 4 root 5 newtons. Don't think you really need to write newtons, but anyway, there's your answer. And last but not least, find the displacement of the particle from its position, initial position, after 10 seconds. Now, the thing is that we've got the initial velocity. The particle's velocity at the end is this. So what we've got to do is, the trick to this is the acceleration is equal to, we've worked out, is equal to 4i minus 2j. Now, the velocity is equal to 4ti, so we're actually integrating minus 2tj, make sure that vector notation, and I'm going to call this plus c. And as you know, the initial conditions are at t equals 0, v is equal to 3i plus 2j. This question was done really poorly too. Now at t equals 0, so therefore 3i plus 2j is equal to, well, that's quite nice, c. So now we've got an expression for our velocity, which is, now we've got to join the i's. So it's 4t plus 3i, and then minus 2t plus 2, minus 2t plus 2 j, like so, plus d, like so. Now, find the displacement of the particle. But we've got to find out what our, we've got to find the displacement. We've only got the velocity. Now, you could do it a number of ways. You could sort of integrate and all that sort of stuff, but let's go ahead. Now, it says a particle's mass with initial velocity experiences a force of this, particle's velocity of this. I'm going to say that at t equals 0, let's say that the displacement would be 0. The initial velocity is this. So let's call let's call it x, like so. X of 0 is equal to 0. Okay, so now what I'm going to do is, let's go for our x is equal to, we've got to go 4t squared over 2 plus 3t I minus 2t squared over 2 minus t squared plus 2t j, and of course we've got to find let's just have a little think about this. Okay, so I just had a little bit of a think about it. At t equals 0, v equals 3i plus 2j. So we've got to find this constant here first. We're almost there, but we're just not quite. So t equals 0, v, so 3i plus 2j is equal to 3i plus 2j. Oh, isn't that nice? Plus d. Our constant vector, d, is equal to 0. Doesn't that
Doesn't that work out quite nicely? So there you go. We've got this, we've got this, we've done this. Find the displacement after 10 seconds. So the displacement is this position vector sort of here. So at if t is equal to 10, we can say that x of 10 is equal to 10 squared is 100, 200, 230i, and minus 10 squared is minus 100, minus 100 plus 20. Minus 80j. Now, it says here find the displacement. The displacement is a vector. So as far as I'm concerned, that's the answer. We better check if it's right. I really should check these sort of things. Okay, let's have a look at it if it's right. Oh, look at that. It's correct. But 37% of students got 0 marks for part A, which is just, it's really polarizing, isn't it? It's the students that know what they're doing and those that don't. Okay, and the second vote, look at that. 53% of students got 0. And that's because, number one, the most common error was using scalars throughout, finding distance rather than displacement. Other errors included attempting to use the constant acceleration formulas without vectors. Okay, so using these are variable forces. You cannot use Suvat equations. Poor recall of the constant acceleration formulas where attempts were made to use these, integrating the acceleration vector, but either without a constant of integration. The constant of integration is what I'm talking about. You need a constant of integration, and it's an integration vector, as I've shown you, plus C vector, this plus D vector, etc., etc. Or getting an incorrect value for the constant. As you can see, not done very well, but not that difficult a question. Now, this whole video covers basically all of mechanics. If you were to study this, if you were to watch this video towards the end of the year, this literally covers everything you need, I promise you. Okay, give or take a few multiple choice questions and things, which you're going to do. So just quite timely to just finish this video on a cough, but I just wanted to wish you all well, and I hope that this video has found you well. I hope that you found it very useful. I know that it's been very long, but Rome wasn't built in a day, and the specialist maths course certainly can't be taught in a few hours. So I hope this has found you well. And of course, if you like this video, stick a thumb up, and or maybe even just make a brief comment if you've got any suggestions. Thank you.